So we're going to continue with radicals. Remember, a radical is something like a square root, or a cube root, or a fourth root, or we can keep going, but we're really only going to deal with square roots and cube roots. Now, all you guys have done up to this point, really with radicals, is I would say, okay, tell me the value of that, evaluate that, and you would get 4. And if I asked you to find the value of that, what would you do? Nope. Don't think doing it in your head. What would you normally do? Yeah, calculate, right? And then you punch it in and you get 4 point something. Okay. Well, there is another thing we can do with radicals. And we can take a radical and kind of like reducing fractions, we can simplify them and show them in a certain way. Okay? And there are 2 things you need to know to do this. The first thing, I'll go down here. The first thing is you need to know perfect squares and perfect cubes. Okay? You don't need to know why, but perfect squares, you should be familiar with those perfect squares. All the way from 2 times 2, 4, up to 10 times 10, 100. Okay? We're not going to use these bigger ones too much. Okay? We're going to use the smaller ones a little bit more. And you have to know some perfect cubes, but not as many. You really only need to know this is good enough. All the way from 2 times 2 times 2, which is 8, to 4 times 4 times 4, which is 64. Okay? So you need to know those in order to do this process. And you also need to know something about multiplying radicals together. What's the square root of 4? Times, what's the square root of 3? So would you all agree that the square root of 4 times the square root of 9 is 6? Okay? But there's another way you could do it. We could multiply the 2 numbers and put it under 1 square root. And I get the square root of 36, which is 6. Notice they're the same. So what does that mean? That means that if you multiply any square root, and I'm just going to call whatever number under A, times another square root, that's the same as multiplying those 2 numbers and putting it under 1 square root. So the square root of 2 times the square root of 3 is the square root of 6. Square root of 4 times the square root of 7 is the square root of 28. Or we could work backwards. I could say, tell me 2 square roots that multiply to get 15. Well, tell me 2 numbers that multiply to get 15. 3 times 5. Tell me 2 numbers that multiply to get square root 15. Square root 3 times square root 5. Okay? That's it. It works the same with cube roots. If you multiply 1 cube root by another cube root, that's the same as multiplying those 2 numbers and putting it under 1 cube root. So like the cube root of 2 times the cube root of 3 is the cube root of 6. Okay? So you have to know this multiplication property, and you have to know these perfect squares. Okay? So here's how we do it. Let's take an example. The only way you guys know how to work with root 27 is to use a calculator, but we're no longer going to do that. We're going to simplify it. So what we need to do is remember, first of all, root 27, we call it an entire radical. It's got nothing else with it. It's just a radical with a number under it. We're going to make it look like a number and a radical together, which we call a mixed radical. And we'll see this in a second. First of all, I can take this and break it down into 2 square roots that are getting multiplied, where this number here is the highest perfect square can't spell. Highest perfect square into 27. Look at your perfect square list. Which of these numbers, the highest one, goes evenly into 27? 9. If this is 9, and if these two multiply gives me this, what has to go under here? 3, because 9 times 3 is 27. Why did I do that? Because what's an easier way to say square root of 9? 3. And this one, I can't do anything with it without a calculator, so that's my answer. And this is what we call a mixed radical. Why? Because it's a mixture of a non-radical being multiplied by a radical. And how do we say that? Usually with these ones, we say it like this. 3 root 3. You don't have to say square. Okay? So let's practice with the cube. It takes a little bit of time to start, but you'll get there. Because it's new. Okay, go away. Thank you. All right, this one. Notice it's cube root. So I'm not breaking it down into 1 perfect square times another perfect square. I'm breaking it down into 1 perfect cube times another perfect cube. And this is the highest perfect cube to 32. Look at that list. Perfect cubes. 8. No, 8. Because 4 is not a perfect cube.
No, 8 and
Oh, sorry, 8 times 4, yes. You're right. If this is 8, this has to be 4 because 8 times 4 is 32. Why did we do that? Because you can do this. What is the cube root of 8? Just say 2 times the cube root of 4. But we don't have to write that little time slot. I know it looks a little weird. You're probably not used to seeing something that looks like that. But that is read as 2 cube root 4. And that's as far as we've gone. So that's when you take an entire radical and you go to a mixed radical. If you're not sure whether perfect squares or perfect cubes go in, use a calculator to help you. Okay, this one. Perfect squares. So this is the first thing I did. Break it up into 2 square roots. The highest perfect square that goes into 28. The highest perfect square that goes into 28.
4.
4. And if this is 4, this must be, because 4 times 7 is 28. Why did I do that? Because what is the square root of 4?
2.
And then I can't do anything with the root 7, because remember, we're not using the calculator to estimate here. Okay? That our answer. Okay, cube roots. Remember, I told you should know 3 cube roots, 8, 27, 64. Which of those, the highest one, goes into 144?
8.
8. That's using a calculator. 8 times what is 144? Well, 18, because you divide. What is the cube root of 8?
2.
2. And then I don't touch the second one, and I'm done. One thing you got to be careful with, sometimes more than one perfect square goes into it. You need to find the highest. Like this one. If I go back to my perfect squares, it should hopefully be pretty obvious to you that 4 goes into 80. But is there a higher one? 16. You need to find the highest. Because if you don't find the highest, okay, you haven't simplified. So the highest perfect square is 16, and 16 times what is 80? 5. And the square root of 16 is 4. Can't touch the second one, so I'm done. I'm going to change the order up a little bit here. I want you guys to try C. Try C on your own. And then I want you to try A. I know I'm going to do it in a different order. So, square roots. Highest perfect square is 9. And 9 times 6 is 54. We did that because the square root of 9 is 3. Don't touch the second one, we get 3 root 6. That's it. Now let's go to A. It's not square roots, it's cube roots. So you got to look at a different list. Use that list to help you. Actually, after, if you flip forward here, got a list here. You've got a list forward you can use too. I would suggest you keep that list handy for the time being, okay? Because like I said, it's a little challenging to start, but you guys will start getting the hang of the numbers. So look at your perfect cubes. Which one goes evenly into 40? Look at your perfect cubes. 8. Which means this must be?
8.
No, 8 times what? It's 40. 5. Why did I do that? Because I can do the cube root of 8 exactly. What times itself gives me 8? 2. Cube root 5. Done. Okay? This last one. Can you find a perfect square that divides evenly into 26? Think of your perfect squares. Does 4 go into 26? No. Does 9 go into 26? No. Does 16 go into 26? No. Does 25 go into 26? No way. And then we're too high. So nothing. So what do? You can't do anything with this. Instead, simplify if possible. So if you can't do anything with it, just leave it. And that's done because you can't simplify. Just below here. Do that one for me. So right away, square root times square root.
Would it be?
4.
And then 3.
And then 3. And root 4 is what? Go further. 2.
2 and 3.
Root 3.
Same.
That's it. Okay? Like I said, once you start doing a few of these, you'll get it. It's just that it's new. It's a new way to show something. Okay, the last thing I want to do before we do an actual example of using that. What happens if we're asked to go backwards? What happens if you start at the answer and you ask to find what radical? Lydia?
For the number, if you're going to do 1 times 4 times 3, instead of choosing 3 times 3, you can start with 3.
Excellent.
Yo!
You have to change 4 to a square root. How do you change 4 to a square root? 4 times 4. It's a square root of 16. And now we can multiply these two into one single square root. Either in your head or using a calculator, you get root 48. So to go backwards, you got to change the non-square root or the non-cube root to a square root or a cube root, and then you just multiply. You're just going in the reverse order. So how do I change 3 to a cube root? Yeah, 3 cubed. 3 times 3 times 3. And you get 27. Now we can multiply these two into one radical, an entire radical, cube root 54. Okay? How would you write 5 as square root? 25, because 5 squared. This is still root 2. Now I can multiply those two to get root 50. Don't forget the root. I know it's hard to get used to. But remember, 25 times 2 is 50. Root 25 times root 2 is root 50. Okay, here's an example where we can actually use it. We got a right triangle. We're asked to find a missing side. What's that formula? A squared plus B squared equals C squared. Pythagoras. Well, remember A and B are the lengths, so it's 3 and 6. So I go 3 squared plus 6 squared, and what have we called the hypotenuse? We called it x. You guys should be familiar with this, how to do this. It's just we're going to show our answer in a different way. So 9 plus 36 is equal to x squared. 45, after I add them, is equal to x squared. So to find x, I'm going to have to take the square root of 45. This is where you would use a calculator. But notice, and I put it in bold, you got to break it down. So break it down. And I'm even going to stop writing that multiplication dot. You don't even need it. If you put them beside each other like that, it means multiplication. Highest perfect square that goes into 45, 9, which means this must be 5. And it goes all, and then it goes to 3
and root 5.
root 5. And you're done. Centimeters. Good. Excellent. So it's the same stuff that you guys have been doing last year and a few years before, except now you're showing your answer differently. Okay?